Hi guys, this is Emily Smith, and today we will be dealing with the analysis of variance working on problem 25 of chapter 20. So the problem talks about different cars with different cylinders and how fuel efficient they are based on their miles per gallon. So first we need to determine the null and alternative hypothesis. The null hypothesis is that there's equal variance between the mean miles per gallons of all the different cylinders. The alternative hypothesis is that there are at least two mean miles per gallons that are different between the cylinders. So now we need to check that the conditions for the ANOVA are met. We look for independence first to make sure all the cylinders are independent of one another, and we are able to determine this because there is only one input for the 5-cylinder, which is 20.3, and it is not included in the 6 or the 8 cylinders. So therefore, if a car has 5 cylinders, it's not also included in the 6 or in the 8. Next, we check to see that the data is randomly sampled. In the book, it says that the study was conducted by a major car manufacturer. However, it does not say that it was randomly sampled, so we cannot know this for sure, but we're just going to assume that it was for the sake of this problem. Next, we check for normal distribution. So we go to the distribution module, and we look under the p-value. So for the 4 cylinders, it's 0.5617. There is no p-value for the 5-cylinder because in order to do the goodness of fit test, you need 2 inputs, and this only has 1. And then so for the 6 cylinders, the p-value is 0.3180, and in the 8 cylinders, it's 0.9861. So because of all these values, we are going to retain the null and say that we have no reason to think that the data did not come from a normal distribution. Next, we check for equal variance, and we will find this in the fit y by x module. And then under the Levine row, we will see that the p-value is 0.0667. And so again, we are going to retain the null and say that we have no reason to think that the data did not come from a normal distribution. Thank you guys.